All right, so some of the things that we have to do is analyze a graph and really give it a good looking over and understand how it moves. And all the functions move the same way. All of the 12 basic functions move the exact same ways. So what we're going to do is we're going to look at a quadratic function, one that you've seen a lot, that you've graphed several times, you're very familiar with. And we're just going to talk about analyzing it a little bit, talk about some of the different things that it does. So one, where does the graph increase or decrease? Well, when we ask about increasing and decreasing behavior, we're talking about y coordinates. Where are the y coordinates going up or down? Okay, and so in this case, if we look at the blue graph, the x squared graph, and we want to know where it's increasing or decreasing, then we're talking about where are the y values going up. And so you can see right here that the y values are going up, but from what point? From the vertex. And it looks like this vertex is at the point 0, 0. So we would say that we increase from 0, and I include it, some mathematicians won't, and there can be an argument for both cases. But I include it, and I say we increase all the way from 0 to infinity, because the graph continues to move to the left, and it continues to grow. Where is it decreasing? Well, it's decreasing where the y values are falling. And if you'll look, the y values are falling to the left side of that vertex. So this is the parent function here, and we would say that it increases from negative infinity to 0. And again, I would include 0. Some people don't. And infinity is never included in brackets because infinity is an idea, not a specific number. Okay, well, what about this x minus 2 squared? So if we look at x minus 2 squared, okay, where does it increase or decrease? And the same rules apply. When we look at increasing behavior, we look at where the y values are getting larger and larger and larger. And it looks like the vertex is here at the point 2, 0. So we're going to go from 2, 0, which would be an x coordinate here. So this is going to be from 2 to positive infinity. This is where my increasing behavior is going to be. My decreasing behavior then is going to be on the other side, where all the y values are falling. So that's going to decrease from negative infinity to 2. Okay, so is the function either odd or neither? Well, the blue function is even. Anything that can reflect over the y-axis and be a mirror image of itself is going to be an even function. This particular guy in red doesn't reflect over the y-axis and become a mirror of itself. If I were to reflect it over the y-axis, if I were to use that y-axis as like the mirror's edge, it would not be the same. So this isn't odd. It's really neither. Odd is a reflection over the line y equals x. So this guy's a neither. Is there any extrema? There sure is. You'll notice that on both of these guys, we have a vertex. And the vertex is what we would call a minimum for this particular problem. And so on this problem, it does have an extrema. It's got a minimum value. So we would say that it's a minimum on both. Now, some quadratics would have a maximum, and we're going to see that there are other polynomials that have several of these. Okay. Now, how does the red curve compare to the blue curve? How does the red curve compare to the blue curve? Well, what's the difference? Notice where those two minimums occur. One occurs at 0, 0. The other occurs 2 units to the right. That's the difference. That's how they compare. So what we've done is we've taken the function x squared, okay, the function x squared has moved 2 units to the right. And that's how they are related.